In this mechanical drawing series, we've drawn the rough sketch, the sectional front elevation, and the plan of the pulley bracket. Whereas in this video, we are focusing on the left end elevation of the pulley bracket. But I'm bringing an additional video. That's the full asymmetric block of the video, where the three elevations will be assembled together, where we draw the block using these elevations. But it's just an additional video, it's not part of the question, but I'll just bring that up. So for the left hand elevation, is the views is not given. Normally we do draw from what is given. We do replicate that in our drawing paper. But this time around it's not given in the question here. So how do we use our eyes, our mind eyes to visualize the left hand elevation, how it will be like? So this is how we do so. Using a rough paper, left hand elevation will be at the left hand side here, which is this part here. So what are we going to see looking at the left end elevation of the pulley bracket? So we'll see this part here, which is the bottom layer of the pulley bracket. So we are looking here. So we are seeing the whole of this part. So for the width, this is the width, and for the height, this is the height. All right. So we have the bottom part, which is here. So the bottom part, the length is 6 cm. So we have the height of this bottom part, which is 1.5 cm here, like this, then connect it. So after the bottom part, remember we have this leg of the arm where it joins with the circular arm here, where it joins. So how do we draw that now? So this is how we determine that. Take note that there's a center line here, which from the air bottom to the center line is 5 cm in height. So we'll just mark 5 cm from this bottom, that's from this center part. Whenever we mark 5 cm, that's from this mark here, 5 cm mark, we mark 1.5, 1.7 cm up, 1.7 cm down. Because remember, the arm here, it's the total length of the arm is 2.4 cm. That's the total length. So from this center line, for us to get the total length, we mark 1.7 cm up and 1.7 cm down, which when joined together gives us a total of 2.4 cm. Here, that's the length of the arm. So that's what we do to get the arm. Remember that the arm is circular in shape. It's not like a square. Remember, because of what we talked about in the previous videos. So if you've not watched that, be able to watch the video so that you get the points. So that's what we do. At this, we mark 1.7 cm up, then 1.7 cm. Then we draw the arm here. Let's say this. That's the arm. Let's just say this is the arm. Remember that in the arm, in the assembled block, what passes through the arm first, what's fitted into the arm is the bush. This bush here is fitted into the arm. Then why it is fitted is because this bolt has to pass through the bush. Then once the bolt pass through, the knot holds the bolt together, which keeps everything fit intact, which keeps them from losing or falling off from the arm itself. When we look at the left end elevation of this assembled block, seeing the knot, that's this knot, the front surface of the knot. So let's insert it in the rough sketch here. So this is should be the knot. It should signify the knot rather. That's in this rough sketch we are drawing. Then we have the head of the boat. And the head of the boat to be here. Let's see something here. And that's all. It's going to be like this too because this part, the total length is 1.2. Then it cuts in. The length at which it cuts is not mentioned, but I moved it by 0.1, 0.1. So the total length here is 1.2, then this should be 1 cm. So this outer one is 1.2, and this inner one is 1 cm. And this is the head of the knot, the surface of the knot, and this is the arm. Then what else you're seeing is the leg of the arm, which is like it's sloping because it's not elevated up, it's not straight. No, it's sloping, which will be like this, and it laps on the arm. So it's something like this, and also seam here. Length is 6 cm, so mark at 3 at the bottom and at the top. So using this center part, we'll mark for the center line where the other components fit in. So mark for that. That's from the bottom part is 5 cm upwards. So this is the center line here. Then from this center line, we mark for the arm. That's the top part of the arm is going to be from the center line 1 cm, 1.7 cm up, then 1.7 cm down. So we mark that. They will draw the circle for the arm. So pin at the center and draw the circle. Pin at the center here. Extend to touch both ends. This and also this. Good. These are the two ends. So draw the circle. So after drawing the arm, what's next is the surface of the knot. That's what we are seeing next, which is this the surface. So the length of the knot is 2.8 cm. That's the length. So from the center line is 1.4 cm up, 1.4 cm down. So it's not going to be in circular shape, as you can see. It's going to be in hexagonal shape. Hexagonal. So we'll draw that. So pin at the point here, touching the center. We cut, pin here, cut, join together. We've gotten that. So using this center line, this invisible center line, we'll mark the 1.4 cm. That's from our 3.4. That's to get the knot, surface of the knot. This is 1.4 here, and this is 1.4. Good. We'll just pin at the points. We don't want to draw the line. So we'll do same thing at the vertical axis. Using the center line, mark 1.4 up and also down. Good. Then after the nuts, what's next is to get the head of the boat. So the head of the boat, okay, we'll not draw the tip first. We'll just draw the head, the body rather. That's the surface that is out. This part here, this edge. So the total length is 1.2, which is from the center line 0.6 up, 0.6 down. For this part, I removed 0.1 from the top and 0.1 from the bottom. So which gives us a total length of 1 cm, which is 0.5 up, 0.5 down. So mark 0.6 and mark 0.5, then draw the circle for the two sides to get the tip and the body rather. So we've done that. Then the next thing is to join the leg of the arm to the body. Remember, it's not elevated up. No, it's being slanted, like it's sloping down. So that's what we do. So from the this part here of the that's we look for the parts where it does not look like it's joining, no, but it looks like it's lapping, like it's staying on top. It's being placed on the arm. So and that place is going to be around here. From this part here, we trace the line, we draw the line down to touch the top of the base. That's the base here, and do same thing here. So that's for the leg of the arm. So we are done with that. We are done with the um, base of the pulley bracket, which is this. And also, when looking at the left end elevation, we do the leg of the arm, which is this, as you can see. But I tried creating a leg such that there are two separate legs. There's a hole in the middle, but I realized that since we're not showing the left end elevation, there's no need of doing that. I just had to put the leg to be straight, like a straight leg, but it's not cut. I hope you do get the point. So that's for the leg. Then we do the arm itself, which is the circular part here. This is for the arm. Then looking at the left end, okay, let's use the sectional front elevation that we use. So for the front elevation, looking at the left end, we also see this what do we call it? The nuts, yes. We see the nuts, which is this. Okay, can see it now. Which is this, the nuts. Then we also see the boat. That's the surface of the boat. We see the tip here where it joins, and also the main body, which are these two. Then remember that it's not only this side we are seeing, we're also seeing, as far as you're looking at the left end elevation, we are seeing everything from the top to the bottom. So if you join from the bottom to this arm, top of the arm, don't forget that there's also the pulley, which extends up when looking at the left end, and it extends up by 0. Okay, that's the total length is 4 cm, and total length of our arm is 2.4. What is remaining is 0.6 cm. So we have to divide by 2. That is from the center line to get the top and the bottom part. That's to draw that. So for the top, what we are seeing is extended by 0.3 cm. So we extend using our compass. We'll take a measurement of 2 cm. That's from this center of the circle to the arm is 1.7 cm in length. So 1.7 cm plus 0.3 cm will give us 2 cm. So we use 2 cm to draw the top of the arm that we are seeing and the pulley we are seeing. So this is 2 cm. So we use that to draw as using the center of the circle. So we'll not draw the bottom because we are the leg of the arm, which is this, comes before the pulley. So we are seeing the leg, but we can't see the pulley because it's behind it. But it's only at the top you can see above the leg of the arm. So from here, we'll draw that. And this is it. This is what we are seeing for the pulley. So that's all for the left end elevation of the pulley bracket. So we are done with the front sectional front elevation as we were told. We are done with also the plan, and we are done with this left end elevation. What's next is the additional video regarding the orthographic projection, that's an asymmetric block of the pulley brackets. We're not taught about that, but I'll draw that to help you understand better. So do well to watch that video. And I know you did enjoy this video, so do well to like, share, comment, and subscribe if you've not done so. See you on the next one.